what's your emergency?
Officers are going to be there any second.
He's going back downstairs.
Leia?
I think you heard the phone ring.
Data storage is a big deal for everyone. Even if you're a student, an employee, or a business owner, you need something in your phone or computer to store and arrange your files. However, a lot of people are unaware of proper data storing practices. Are you among those people who find the terms database, data warehouse, and data lake confusing? In this video, we will know their differences and how they relate to each other. Database is a collection of information or data that is stored electronically in a computer system. It is the easiest to create, and you can query and report on the data using SQL or the structured query language, a standard language for the creation and manipulation of databases. A data warehouse, on the other hand, is a special type of database that is primarily designed to put together the information from the database or multiple sources in a table or a centralized place, then use this information to do an analysis and reporting. Therefore, it is a single source of truth of valuable data assets, and unlike database and data lake, data warehouses are integrated, structured, and summarized. Finally, the data lake is often compared to a data warehouse as they both store multiple data. However, it is not as organized as data warehouse because data lake stores data that is either structured, semi-structured, or unstructured. In simple words, data lake is flexible when it comes to storing data since it has the capacity to store raw data or its original format. It is like a place where all the data can be dumped and stored temporarily until a data warehouse is created. An ETL tool or extract, transform, and load is software that automates the process of extracting, transforming, and loading data from one source into another, such as data warehouse or database. It's a crucial part of any data warehouse project because it ensures consistency and accuracy, which are critical elements in ensuring that business decision makers can use data effectively. Understanding the stage benefits and best practices of ETL processing is to designing the implementing ETL process effectively. Data mart can be called as mini data warehouse design focused on a single subject or line of business that shows the content to be needed only the client side. It holds the overview of data that can access data and gain insight faster because they don't have to spend time searching within a more complex data warehouse or manually aggregating data from different sources. The primary purpose of using it is to get the only information required that can be not very easy to get from the warehouse. To get the source data for Data Mart, to be sure to find an ETL tool that will allow you to connect to your existing data warehouse or other essential data sources that your business user need to draw insight from. In addition, make sure that your data integration tool can regularly update the Data Mart to ensure that your data and the resulting analytics are up to date. A Data Mart can be created from an existing data warehouse, the top-down approach, or from other sources such as internal operation system or external data.
Good evening, ladies and gentlemen. Today, I invite you to embark on a journey into the hidden world of data warehousing, a concept often obscured by its technical nature, but one that holds immense power and potential for those who can navigate its depths. A data warehouse is a centralized repository that integrates data from various sources within an organization to support businesses, intelligence, reporting, and analysis functions. The features of a data warehouse include scalability, data integration, data quality, schema design, historical data storage, and query reporting performance. The architecture of a data warehouse consists of different components and layers, including the traditional enterprise data warehouse architecture and modern data warehouse architecture. The layers within a data warehouse architecture include the staging area, data integration layer, dimensional modeling layer, and presentation layer. Absence in data warehousing refers to missing or incomplete data within the data warehouse, which can occur due to data entry errors, system issues, or unavailability of data during extraction. The types of absence in a data warehouse include missing values, unknown values, and unmeasured unavailable data. Addressing absence involves data imputation, flagging missing data, and conducting data completeness analysis. The presence of absence in a data warehouse can impact accuracy, introduce bias in insights, and affect decision making. The benefits of a data warehouse include improved data quality, data integration, enhanced data accessibility, support for advanced analytics, historical data analysis, improved decision-making, and operational efficiency. These benefits contribute to better data utilization, informed decision-making, and operational effectiveness within organizations. Overall, a data warehouse serves as a reliable and comprehensive source of truth, providing accurate and integrated data for analysis and decision-making purposes.
The analysis of data-oriented structures is known as data modeling. This procedure entails describing a sophisticated software design in a detailed diagram using symbols and sentences to indicate the direction your data must flow. Also, this detail-oriented diagram serves as a blueprint for creating new software or re-engineering an existing application. Any software development that makes database objects stored and manipulate data can benefit from using a data model. Data modeling and class modeling are quite similar. While data modeling aids in recognizing entity types, a class model is utilized to identify classes. Data models were typically created throughout the project's design and analysis phases, enabling users to comprehend a new application's needs fully. Additionally, presenting conceptual, logical, and physical data models that have been carefully throughout enables everyone involved to find mistakes and make necessary corrections before the computer code is generated. Instead of focusing on what operation should be carried out on the data, data modeling focuses on how your data should be organized and what data is necessary. So what are the three types of data models? So the first is a conceptual data models. It is used to communicate business structures and concepts at a high level of abstraction. Business stakeholders and data architects typically create these models to define and arrange the information required to establish a system, but they do not consider system restrictions. The second is logical data models. It is concerned with the types, attributes, and relationships of the entities that will inhabit the system. A data architect will frequently produce an analytical model that business analysts use. The objective is to represent the entities and their connections independent of the platform. Organizations might gain insight into the constraints of their present technologies at this step of the data modeling process. The third is physical data models. When using a particular database management system or DBMS, it is specify how logical data models will be implemented. They are constructed using present or anticipated technical capabilities. Database developers and analysts use physical data models to implement the concepts and procedures honed by conceptual and logical models.
A data model is a representation of how data is stored in a database. It is a diagram with a few tables together with the relationships between them. The art of dimensional modeling focuses on the dominant read operation of the data warehouse, instead of a dominant write operation of a transactional system. Dimensional modeling helps build a data warehouse that is efficient for analytics and also make it easy for the user to understand the data, so they can be self-sufficient in their queries. The primary operation in the database is the read and write. We can represent the write operation as a pencil, and on the other hand is a magnifying glass, and a database as a sheet of paper. Writing on paper using a pencil is equivalent to a write operation on a database. It is for the single pencil, but what happens if a multiple pencil are trying to write on a single sheet of paper? It won't be possible for a single person to use multiple pencils to write at the same time. We can simply assume that many people attempt to use their pencils to write on a single piece of paper. They could be attempting to write on different parts of the paper or the same part of the paper. This situation will be chaotic if we didn't apply some sequence to it. Hence, we need to plan who will write first and where. So there is one way to address this problem, and it is to tear the paper into smaller pieces in a sensible manner, and let the authors choose which piece of paper they want to write on. The same happens when the multiple users or application attempt to write to a single table in a database. It helps to break down on large table into smaller tables. We can now understand the read operation in the same manner. The magnifying glass in a piece of paper represents a read operation on a database. The magnifying glass enables one to read the text from different pieces of paper. However, it is advantageous to do so. To do so, it will be a lot better to have all the text that is needed on a single piece of paper. So for reading, it will be better to have all the text in a single piece of paper, whereas it is the opposite and if the intention is to write. This applies to a database read operation. If there is one table that has all the data that is needed to read, then it makes things a lot easier and efficient. A write operation needed a table design that involves breaking down into smaller tables. An application that involves mostly reads will be efficient if the table design involves fewer tables. A data warehouse is an example of data warehouse that requires a small number of large tables due to numerous users required to read a lot of data. A characteristic of data warehouse is to write data once and read it many times. Read operation is dominant in a data warehouse.
The data modeling diagram is used to create or view graphical models or relational database system schemas, including a range of database objects. The diagrams can be drawn at a logical or a physical level. When a physical schema is being represented, the modeler can choose the correct RDBMS, which will enable the appropriate data types. Tables, views, stored procedures, and the other objects are connected, showing the way they are related to each other. The data modeling diagram can be used to create database schemas or to view schemas that have been reverse engineered from a live database connection or transformed from a more primitive model. It is a useful diagram to visualize the connections between a variety of database objects. They can also be used to show traces back to other elements such as the requirements, logical components, and business rules. So what is normalization? Normalization is used to remove redundant data from the database and to store non-redundant and consistent data into it. It is a process of converting an unnormalized table into a normalized table. Database normalization is an important process because a poorly designed database table is inconsistent and may create issues while performing operations like insertion, deletion, updating, and etc. What is denormalization? Denormalization is used to combine multiple table data into one so that it can be queried quickly. It is a process of storing the join of higher normal form relations in the form of base relation that is in a lower normal form. The primary goal of denormalization is to achieve the faster execution of the queries. The basic difference between normalization and denormalization is that the database normalization removes the redundancy of data and anomalies in a poorly designed table, while denormalization combines multiple table data into one so that it can be queried quickly. Having access to data from multiple sources can lead to better, more informed decisions. By identifying correlations and trends across data sources, your team can make decisions based on a complete understanding of your business landscape. Using a variety of sources can diminish the effects of bias, the preference of one view over another. Bias may prevent objectivity and often leads to an incomplete representation of information. If blatant bias is present in a source, compensate for it with viewpoints from other sources. Using multiple perspectives in this way will help you create a well-rounded source other researchers can use.